Welcome. A happy Day of the Dead and Halloween. I'm Diana Bartlett, and I've been teaching happily at Madison Central High School here in Kentucky for several years. And I've also been performing shows for over 20 years. So even though this year will be different, I'm going to take you on a journey through some spooky science demonstrations. And I hope you enjoy these, but also learn some of the science behind them. All right, come with me. Now, I have brought some of my favorite flowers. I have here some lovely white hydrangeas, but what if they were another color? My granddaughter's favorite color is pink. So let's see if I can use my chemistry powers to turn them into some pink hydrangeas. Oh, she is going to love these. Pink is just her favorite color. Oh, look at that. Now I have some pink color, flowers for my granddaughter. But wait a minute. I don't know. I really would rather them be white. So let's turn them into some white flowers. I think I like that better. Well, I don't know. She loves pink. I've got to turn them back into pink. All right, let's try again. Oh, look, oh, she's gonna be so happy. Now I have pink hydrangeas again. But I really want white. Well, we're just gonna have to turn them back into white. So now I have my white flowers again, and when she comes over, I'll just have to turn them back into pink. Okay, so let's talk a little bit about the science behind this. Now, what I have done with these flowers, and they're fake, they're fake flowers, silk flowers. So what I did was I took and I covered these, I dunked them into a solution that had an indicator, and this is an acid-base indicator. Well, the indicator that I have is called phenolphthalein, and phenolphthalein is a substance that when you put it into an acidic solution, what it's going to do is be colorless. And then when you increase the pH around a pH of 9 and above, it turns that beautiful fuchsia pink color. So what I did was the phenolphthalein is already on these flowers, and it will stay there until I wash it off. So I've been doing this with this for about 5 years. So still working. So what I have in here is some ammonia. And ammonia is a base. So what I've done is taken this ammonia, and when I spray it onto the flowers, now what's happening is the basic solution is turning the phenolphthalein into its basic form. Now, when I shake it in the air, it's being oxidized, and when it oxidizes, it goes back and into the acid form, which is colorless. All right, I promised you some spooky science, so here it comes. I had the opportunity to do a mini internship in NASA down in Houston, Texas this past summer. Well, the research that they were doing was very interesting. They were experimenting with different types of solutions to see if they could take and expand the capillaries under your skin and bring blood up to the surface of the tissues or the skin. So they actually let me have some. So I actually got, some of this solution from NASA. They were very gracious. So what I'm going to do is I'm going to I'm going to spray this on my skin and see if we can get the blood to come up and show you. Now, when I spray it on there, it doesn't bring the blood so you can actually see red blood. So we have to put it onto something so that I can actually see it. So what I have here is some paper, and what I'm going to do is I'm going to spray the solution on my hand. I'm going to wait a minute, let it activate, and then I'm going to touch my hand to the paper surface so you can actually see it. Okay, so I'm going to spray this. This is my NASA solution. I will spray that on my skin. You can see that it's getting wet. Let's put a little bit more on it. Okay, it's starting to tingle. So let's take a look. So I am going to apply this to the paper. So you can see that the blood did come from my hand. Okay, now what I'm going to do is I'm going to show you one of my favorite pets. I love having pets in my classroom. I've had everything from hedgehogs and guinea pigs and mice to snakes, which I currently have a snake that resides in my classroom. But this pet is a special one, and he's very shy. Sometimes he's hard to see. His name is Oscar, and I have tried to feed him all kinds of different things. I've tried cat food, mice food, I've tried hamburgers and broccoli and brownies, and he does not like those. What his favorite thing to eat is styrofoam cups. All right, Oscar, wake up. It's dinner time. All right, so let's see if we can see him eat. All right, Oscar. Oh, yes, that's a yummy, yummy styrofoam cup. Okay, so as you see, he is eating it. You think he's still hungry? Let's try some more. Oh, he's a hungry little monster. Maybe I'll try another one. See if he'll eat that one. All right, how hungry are you, Oscar? Oh, I think he is. Now, you that out there that have pets, you know exactly what happens after pets eat. They are going to poop. And so what we're going to have to do is now clean up Oscar's cage. So let's see if we can clean up his poop now that he has eaten and we have a mass of poop left. All right, so, oh, poop is so much fun to play with. Oh, yes, look at that. Oh my gosh. Yes, Oscar poop is wonderful. I wish you were here to feel it. It is so cool. So, I can stretch this, and as I stretch it, and as it starts to starts to harden, it starts getting a little bit less and less stretchy. Now, a lot of times I will not tell you how to do things because you don't have the education and experience needed, to actually do these demonstrations and to understand what's going on. But this one I will tell you. So if you want to do this at home, it is so cool if you have, someone that may be a little interested in science. So get a glass bowl. Plastic doesn't work very well. And then if you were here, you could smell and know exactly what I have in little Oscar's cage. So if you see, I have a liquid in there. Well, what that is fingernail polish remover. Now you can get this at the store, but it has to be 100% acetone. Don't get the kind with all the extra additives, that keep your skin from drying out. You need the real stuff. The other thing is you need some styrofoam cups. Now Oscar will eat styrofoam plates and bowls, but his favorite is styrofoam cups. But you have to get the cheapy kind. Go to the dollar store. If you get the more expensive kind, what they've done is they've coated it so that it won't break down as easily. Okay, then you can play along with Oscar's poop, and as you see, it's getting less and less stretchy. What you have here is what styrofoam is made from, which are basically little plastic pellets. And what they do is they will dissolve it, heat it, and then they will pump air into it and put it into a mold, and that's how you get styrofoam. A lot of people are trying to recycle styrofoam, and this is a way of transporting it, is taking and reducing the volume, and then this is much more easily recyclable. All right, so what you do is just do what I do, and you can leave this out once the acetone has all gone away and evaporated. You'll be left with a hard piece of plastic. Okay, I learned this by serendipity. As a young graduate student, I was trying to finish my experiment. I had some glassware to wash up, so I washed it, but I had to rinse it with acetone to get off organic material. So I was in one part of the lab, my lab station was over in the other, and I got a little lazy. So I went to the stock room and found the acetone, but I forgot to bring a beaker with me. Well, the coffee station was right around the corner, so I went over there and grabbed a styrofoam cup. I was like, that'll be good enough, it's clean. Nobody's used it before. So I pour my acetone in there, and I'm happily walking back to my lab station, and all of a sudden the bottom of the cup falls out, and I have acetone all over my shoes, pants, and the floor. And years later, I started, I remembered that incident. So serendipity is when good things happen by chance. So not all mistakes are bad. You make mistakes or something, it might turn into something good. So it turned into a pretty cool demonstration. Hope you enjoyed it, and try this at home. And now I want to show you something that I got on another one of my trips over the summer. Well, a couple years ago, I actually had the chance to go to Transylvania. And over in Europe, they were doing lots of different digs, archaeological digs, and they're very interested in finding bones of, ancient creatures, especially dinosaur bones. So I happened to have the opportunity to acquire a dinosaur bone. So I brought it home, freeze-dried it, I ground it up and made it into a powder, and now I want to show you how we are going to awaken the spirit of the dragon. So I have here my dragon bones. Now, I want to show you that, if I just try to burn them, let's take a little bit of fire, and I just try to burn those dragon bones, get them to catch on fire, they're not doing it. We have to know the secret. And the secret is you have to say the magic words. No, I heard that out there. It is not, alakazam or abracadabra. No, science rules. Those are the magic words. So I'm going to see if we can awake the spirit of the dragon. All right, on the count of 3, everybody say it with me. 1, 2, 3. Science rules. Yes, I got him. I got the dragon to awake. Let's try again. Let's see if this still works. Okay, 1, 2, 3. Science rules. Yes. Now, I want to show you the secret and the science behind this. Of course, these are not real dragon bones. I wish I could have real dragon bones, but no, I don't think you can find them anywhere. What this is a powder, and is a powder that comes from mushrooms. It's called lycopodium powder. Makes a very extremely fine powder. So, if you look at it, see if I can show it to you. Okay, so I want you to look at this powder. It's kind of a yellowish powder, very, very fine. Okay, so I try to burn this, and it does have a lot of surface area, but the surface area is not combining with the oxygen. So I need to make it into a fine mist in the air in order for it to have a lot of surface area to react with the oxygen. So what I do is I take some of this and I put it into this little plastic Pasteur pipette. And then when I squeeze this, it comes out into a fine powder. Once it hits the Bunsen burner flame, then it ignites and catches on fire. If you live in any of the states where there's a lot of granaries, there's been a lot of dust fires, because if something gets into a fine powder, it can catch on fire with some devastating consequences. So, I'm going to just use a little bit of my lycopodium powder. But once we get to reactions, you'll understand a lot more about, the larger the surface area, then the greater the speed of reaction. Now what I'm going to do is I'm going to show you the witch's flashlight. You mortals have your own flashlights, and they are adequate. But for us witches, what we need is something a lot more powerful. So I want to show you our witch's flashlight. Okay, so what I have here is your mortal flashlight. This one has a little bit more technology to it, and it's adequate. But now I want to show you the most powerful and stupendous of all of the flashlights. Are you ready? Oh, that was wonderful. Now, unfortunately, it doesn't last a whole long time, but let's try that again. Now, you are lucky that you are not here, because if you were here, then this would burn your eyes to a crisp. It is so powerful. It is not for mortal eyes. So be thankful you are in camera. Okay, so now let's put on our lab coat of science and see what is going on behind the witch's flashlight. Well, I happen to have here a very soft metal. This is magnesium. And if you know a little bit about the periodic table, magnesium is number 12, atomic number 12, and it is in the alkaline earth metals. Most of those are very soft. They will react with water, but not as violently as group 1 does. Okay, so usually what they'll do is they'll have magnesium either in little, fine little strips or in a coil. So here I have magnesium. Notice it is extremely flexible, and so we can bend it, shape it, and I also can take this and I can tear it just with my fingernails. So extremely soft. Now let's watch when I put it into the flame. Okay, here I have a pair of tongs, and you should specifically know if you watched my equipment videos, these are crucible tongs. Okay, so I'm going to take this, I'm going to put it into the crucible tong so I can hold it into the flame. Okay, so I need a source of ignition. I have my oxygen already, and this is a flammable metal. When you think of metals, you don't tend to think of them as being flammable, but some of them are. Okay, so what I'm going to do is I'm going to get started, and what is happening is that this is completely burning. It's forming an oxide, specifically magnesium oxide. And so what I have here is the ash, and that is magnesium oxide. So it has combusted and it is oxidized. The light that it puts off is fairly intense. It has a very bright light. But if you're into photography, way back in the 20s, 30s, when they used cameras, they would have this big bulb, and in order to illuminate the area, they would, it would electronically ignite, and it had magnesium shavings in it, and so that would combust all at once and produce this extremely bright light. if you watch fireworks, you know, 4th of July or other times, and if you see one of the fireworks, one of the light displays that has this intense bright white light, you can say, ah, there's magnesium in them there fireworks. And that is how they get different effects, is by putting different chemicals into the fireworks and letting them combust. Okay, now I'm going to show you my sizzling, slithering snake. And what I'm going to do is a combustion reaction. I'm going to take a soapy solution. I've added a little bit of sugar to it. See if you can figure out why I added a little sugar to it. And I have the gas connected. And this is just lab gas, same type of gas that you have, you know, in your house if you have a gas cook stove. So the gas is going to come out, it will bubble through here. And what I want is not just the gas, but I want to catch that gas. So I'm going to catch that in some bubbles. Now when you blow ordinary bubbles, you're taking your breath, which is some carbon dioxide, oxygen, and a lot of nitrogen. And you're blowing those up. Well, they're not truly, flammable. So let's take a look at a flammable gas and how this will react when we catch it on fire. Now you should know that there's the fire triangle they probably taught you in elementary school, and there's 3 things that a fire needs. Let's see if you can figure them out. Well, first of all, you need oxygen. Most fires will not burn without oxygen, so we get that from the air. Secondly, you need a fuel. You need something that is flammable, and then you need a source of ignition. Well, I happen to have that right here. Okay, so what I'm going to do is I'm going to turn this on. I'm going to turn on the gas. And if you remember from my safety videos that the gas is on when the lever is parallel to the hose. When it's perpendicular, it's off. Okay, so I can see this is definitely on. The gas is bubbling up through my solution, and now I'm forming bubbles. Now I put a little bit of sugar. Sometimes you can put glycerin, and it just makes the bubbles less prone to pop. So I'm going to take this, I'm going to let it go for a moment, and then we will come back and I'm going to dim the lights, and let's take a look at a combustion reaction. Okay, now that I have a nice amount of bubbles, what I'm going to do is I'm going to bring it down and I'm going to put it onto the lab bench surface. My lab bench is pretty tough. So I'm going to put these to get them to stick onto the bench. And now I'm going to ignite it. So let's watch this combustion reaction. So here we go. How was that? Okay. So combustion reaction, is it exothermic or is it endothermic? You probably remember from some of your other classes. Endothermic, you need to supply heat to it continuously. Here, I added a little bit of a flame, but that was just for my source of ignition. So it is exothermic because you can feel the heat, and it will keep burning on its own until all the fuel or the oxygen is used up. And some of your combustion products, if it is a complete combustion, which this was not, but if it were, you need to know these combustion reaction products are carbon dioxide and water. Believe it or not, combustion reactions produce water, and it basically was in the form of a water vapor. So, hope you enjoyed that. Okay, now what I'm going to do is I'm going to show you one of my favorite pets. I love having pets in my classroom. I've had everything from hedgehogs and guinea pigs and mice to snakes, which I currently have a snake that resides in my classroom. But this pet is a special one, and he's very shy. Sometimes he's hard to see. His name is Oscar, and I have tried to feed him all kinds of different things. I've tried cat food, mice food, I've tried hamburgers and broccoli and brownies, and he does not like those. What his favorite thing to eat is styrofoam cups. All right, Oscar, wake up. It's dinner time. All right, so let's see if we can see him eat. All right, Oscar. Oh, yes, that's a yummy, yummy styrofoam cup. Okay, so as you see, he is eating it. You think he's still hungry? Let's try some more. Oh, he's a hungry little monster. Maybe I'll try another one. See if he'll eat that one. All right, how hungry are you, Oscar? Oh, I think he is. Now, you that out there that have pets, you know exactly what happens after pets eat. They are going to poop. And so what we're going to have to do is now clean up Oscar's cage. So let's see if we can clean up his poop now that he has eaten. And we have a mass of poop left. All right, so, oh, poop is so much fun to play with. Oh, yes, look at that. Oh my gosh. Yes, Oscar poop is wonderful. I wish you were here to feel it. It is so cool. So, I can stretch this, and as I stretch it, and as it starts to starts to harden, it starts getting a little bit less and less stretchy. Now, a lot of times I will not tell you how to do things because you don't have the education and experience needed, to actually do these demonstrations and to understand what's going on. But this one I will tell you. So if you want to do this at home, it is so cool if you have, someone that may be a little interested in science. So get a glass bowl. Plastic doesn't work very well. And then if you were here, you could smell and know exactly what I have in little Oscar's cage. So if you see, I have a liquid in there. Well, what that is fingernail polish remover. Now you can get this at the store, but it has to be 100% acetone. Don't get the kind with all the extra additives, that keep your skin from drying out. You need the real stuff. The other thing is you need some styrofoam cups. Now Oscar will eat styrofoam plates and bowls, but his favorite is styrofoam cups. But you have to get the cheapy kind. Go to the dollar store. If you get the more expensive kind, what they've done is they've coated it so that it won't break down as easily. Okay, then you can play along with Oscar's poop, and as you see, it's getting less and less stretchy. What you have here is what styrofoam is made from, which are basically little plastic pellets. And what they do is they will dissolve it, heat it, and then they will pump air into it and put it into a mold, and that's how you get styrofoam. A lot of people are trying to recycle styrofoam, and this is a way of transporting it, is taking and reducing the volume, and then this is much more easily recyclable. All right, so what you do is just do what I do, and you can leave this out once the acetone has all gone away and evaporated. You'll be left with a hard piece of plastic. Okay, I learned this by serendipity. As a young graduate student, I was trying to finish my experiment. I had some glassware to wash up, so I washed it, but I had to rinse it with acetone to get off organic material. So I was in one part of the lab, my lab station was over in the other, and I got a little lazy. So I went to the stock room and found the acetone, but I forgot to bring a beaker with me. Well, the coffee station was right around the corner, so I went over there and grabbed a styrofoam cup. I was like, that'll be good enough, it's clean. Nobody's used it before. So I pour my acetone in there, and I'm happily walking back to my lab station, and all of a sudden the bottom of the cup falls out, and I have acetone all over my shoes, pants, and the floor. And years later, I started, I remembered that incident. So serendipity is when good things happen by chance. So not all mistakes are bad. You make mistakes or something, it might turn into something good. So it turned into a pretty cool demonstration. Hope you enjoyed it, and try this at home. Okay, since we are at the time of Day of the Dead and Halloween, I'm going to tell you a spooky Halloween story. And this was a story that one of my friends told me when he went out with another of his friends. Well, I'm going to illustrate it for you too. So my story goes like this. My friend Dracula was out with his friend Wolfman. Well, they were going to a concert and they wanted to do it up in style. So what they did was they got a limousine, they had a chauffeur, they went out to dinner. Well, they took a little bit longer at dinner than expected. And the chauffeur's like, come on guys, we've got to go. There's, not much time to get to the concert. And so the chauffeur said, I know a shortcut, so let's take the shortcut and, see if we can't get to the concert faster. So off they go. And all of a sudden, as they're going down the road, tire blew out. And so the chauffeur had to move over to the side of the road, and he's like, guys, this tire is a goner. I have got to change it. Well, it happened to be summer, and it was very hot. And so what they did was they were like sweating, like, what do we do? The chauffeur said, there's a little house over there. Why don't you go over there and see if you can get something, maybe to drink, or at least get out, out of the sun. So they went over and they knocked on the door, and a little old lady comes out, and she's like, well, they look a little strange, but they seem like they're nice people. So she invited them in and sat down on the sofa, and she said, well, would you all like something to drink? So, she didn't have a whole lot, but she said, well, I'm going to try to do the best I can. So Wolfman said, I think I'd like a smoking zombie. And she's like, well, I'll do the best I can. And so Dracula said, I'm on this diet. Can you give me some cherry Kool-Aid? She said, well, okay. So now let me show you how she made her drinks. She went over to her refrigerator, and all she could find was this, pitcher of water. So she's going to do the best she can. So what did Dracula order? Ah, yes, cherry Kool-Aid. Wolfman, what did he want? Ah, yes, smoking zombie. Okay, so she puts them down on the coffee table, and they're just about ready to get their drinks, and then all of a sudden, there's the chauffeur. He's like, come on guys, I got the tire fixed, we gotta run, and so they said, oh, thank you so much for your hospitality, we appreciate the drinks, but we've got to run. And so they ran out the door. Well, here she is with these drinks, and she doesn't know what to do with them. She's like, I really don't want to drink them, maybe I'll just put them back and, I can drink them later. So she puts them back into the pitcher. And then she will put them back into her refrigerator and conserve. All right, hope you enjoyed my story. Okay, so let's discuss some of the science behind my little story. Well, if you know some things about acids and bases, and as a chemistry student, you will learn to, understand what an acid is, what a base is, how when you combine them, they neutralize, what are indicators, which are kind of like a dye, but they have two different forms. So if you put it into an acid, it will have one color. It'll have a different color with the base. Now, depending on which one of these indicators you use, you'll get different color changes. Well, I happen to use phenolphthalein. Remember, it's the one that I used on my flowers. So what I did was I put a little bit of phenolphthalein in the bottom of the cup. Hopefully you couldn't see it. In the bottom of this one, I put a small amount of hydrochloric acid, concentrated. So I have to be careful, and I have been doing this, for over 20 years, so I know how to mix them with and be safe. Now, the hydrochloric acid in this, I have to get it somehow to smoke. So what I did was, in the pitcher I have water, and then I put a small amount of just household ammonia. Now ammonia is a base, and so I have this. It's a not very concentrated solution, more of a dilute solution. So when I poured this into the phenolphthalein, the base made it turn that beautiful fuchsia pink, and so that's why it poured up pink. Now when I poured this into the acid, I have ammonia reacting with hydrochloric acid, and it's forming ammonium chloride, which you'll learn how to write the formula later. And ammonium chloride forms this kind of a very, very fine powdery mist, and it happens to be an exothermic reaction, so this gets us slightly warm. Now if you remember which one of these did I pour back first, that was important. I always pour the acid back. Pouring the acid into here, it neutralizes my base, and now I have an acidic solution. So then when I had my beautiful, cherry Kool-Aid, when I poured it back, as soon as this solution hit the acid, this indicator, phenolphthalein, boom, it just went immediately back to its colorless form because there was so much acid in here. So I hope you like that little explanation, and you will get a much better understanding once we get to the topic of acids and bases. Okay, now what we're going to do is I'm going to make something that one of my good friends asked me to do. So I decided, well, what better time to, make something for him, my friend, than, on my show while you all can watch. Now, this is not easy to do. My friend happens to be Frankenstein, and you probably know, just how gunky his teeth are. You don't want to be around him when he's talking near you. It's terrible. Well, he wants me to make him some toothpaste. Well, Frankenstein, he can't just use any old toothpaste. So he has to have it specially made. So we're going to make him a custom toothpaste. And I want to show you how strong it is afterwards. All right, so I happen to have my main ingredients. I have gnat wings. I have goblin fingers. And my most important one, spider distillate. Okay, and I have a few other secret ingredients, but I'm not going to tell you those. All right, so let's see if we can make the monster toothpaste. Well, I think we're making plenty for him. Oh, yes. He is going to be happy. The problem is going to be trying to get it through the little mouth of the tube, but we'll worry about that later. Oh, look at the steam coming off. Yes, that's going to be strong enough to peel anything off of those nasty, gunky teeth. Now, I want to show you just how powerful it is. So I have some wood splints, and I'm going to see if I put some fire inside of it, what will it do? Okay, it's getting a little wet, but as you know, look at it going in. What it's doing is it's combusting. Okay, so what does that mean? Well, it's strong enough for my friend Frankenstein, but let's take a look at the science behind this. What I have here and my spider distillate is actually hydrogen peroxide, but it's a very strong concentration, one that you cannot purchase unless you're with some kind of a school or research lab. So it's very, very concentrated hydrogen peroxide, same type that you put on your cuts. And what happens is it decomposes when you put it onto a cut or a scrape, and as soon as it hits the blood, there's an enzyme in the blood that decomposes it. And that's why you see the fizzing. So it's breaking down. The H2O2, hydrogen peroxide, is breaking down into water and oxygen gas. So the bubbles you see here, those are oxygen. Now, if you take a look at main gases that are produced by chemical reactions, you have nitrogen gas, which is same in the air, so it kind of does nothing. You have carbon dioxide, which would put it out because it does not support combustion. You have oxygen gas, which if I put this in here, I can see the flame getting brighter. Let's try it up here. So notice that it doesn't go out, it actually gets brighter. So if it were nitrogen, then pretty much nothing would happen. If it were carbon dioxide in those little tiny bubbles in that foam, the fire would go out. Okay, we got two possibilities, hydrogen and oxygen. Hydrogen, you probably know, is a very combustible, flammable gas. So this thing would blow up and I wouldn't be here to finish the rest of my demonstrations. If you are into history, then you probably know about the Hindenburg, which was a blimp, kind of like the Goodyear blimp, but instead of filling it with, helium or some other gas that's not reactive, they filled them with hydrogen gas. And a spark set it off in this ship that had 200 passengers on it, crashed and burned. So it is extremely flammable. This, as you see, is the splint test. So this is a wood splint, and if we test it with a splint, if it pops or explodes, it's hydrogen. This obviously is oxygen gas. So that is one of the things that you will be testing as a chemistry student, is to see what type of gas is produced in certain types of reactions. Now, I have had something extremely special happen. Well, I caught a goblin. And if you've had any experience with goblins, you know that they are horrible little creatures, these little green creatures that you can kind of see out of the corner of your eye and they run around. Well, you know how, like, when you can't find your shoes in the morning, you're late for school, it's not your fault, it's the goblin's fault. They hid those shoes. Or you're walking across and you've got a bowl of soup and you trip and fall and the soup goes all over your mom's favorite rug. It was not your fault. It was the goblin. So one of my goals is to catch goblins, and every year around this time I go hunting for them because they're a little more visible around Halloween. And I actually caught one. It's been plaguing me for a long time, and now I'm going to get rid of him. So I have taken my goblin and I've stuffed him into this jar. And what I'm going to do is I'm going to catch him on fire. So we're going to make him burn up so he can never come back and haunt me again. All right, so let's see if we can make him into toast. So you have to be quiet because sometimes he'll scream when he burns up. But know that goblins are so nasty. We don't want them around. All right, are you ready? Let's get rid of this goblin. All right, goblin, you have been problem enough in my life. You're be gone. Yes, we got rid of the goblin. He is toast, he is no more, and I will now not be late for school because I will be able to find my shoes. Well, everyone, I hope that you have enjoyed my show, even if it's virtual. I've hoped you've had a little bit of fun along with me and learned a little bit of science also. Hopefully next year we will be able to come back and actually celebrate Day of the Dead and Halloween in my classroom with all of my normal craziness. So I hope to see you next year, and I'm so glad, I don't know if I can finish this. I really need something to drink. All these demonstrations just made me so thirsty. So just wait a minute. Let me get something to drink. You know, maybe some water will help. I don't know. Water's kind of, yeah. Maybe I can do something else I can do. You know, maybe a nice little glass of wine. It looks pretty good, but I don't know. Wine has alcohol, and you know, alcohol kills brain cells, and I think I need all the brain cells that I can get. Let's see what else. Oh, now, you know, I might take a nap, you know, after a while, so maybe a nice glass of warm milk might help. Okay. Now that looks real delicious. Maybe, maybe instead of milk, maybe some apple cider. Do you think that would work? Ooh, now that looks like it's going to hit the spot. Okay, so I'm going to enjoy my apple cider. Thank you all, and I hope you have a delightful Day of the Dead and a happy Halloween, and love you all. Peace and joy. Bye.